Hi, buddy. I'm Mike Nelson. Boy, this is the time of year we get a lot of variety in our weather, from great snows in the mountains to strong thunderstorms on the plains, and sometimes they happen all in the same day. This was April a few years ago. Severe thunderstorms and tornadoes on the eastern plains, and up in the high country, heavy snow. So there's a little primer on severe weather. We'll talk about some basic meteorology, tornado background, the beauty of storms, how tornadoes form, how we rate tornadoes, the EF or the Enhanced Fujita scale, other weather hazards, and I'll give you some good weather resources that you can depend on. Well, first of all, where do our storms come from here in Colorado? We get our main storm systems from three different areas. Pacific cold fronts that come in off the Pacific coast. Those oftentimes will bring us some heavy mountain snow, but a lot of times not all that much weather down on the plains. Alberta clipper storms that will be low pressure systems that clip out of Alberta province of Canada and go to the north of Colorado. Generally don't bring us much precipitation but create a lot of wind. And the Colorado hooker, when that big red L forms right down over southeastern Colorado. That's also called the Albuquerque low or the Panhandle low, and that one swings a lot of moisture around the low pressure system and brings us some of our heaviest storms, snow and rain. So the weather makers in our state are really the mountains. Rising air tends to cool, condense, and its moisture is squeezed out. Sinking air tends to dry out and warm up. So that's why you can sometimes have rain or snow on one side of the mountain and sunshine on the other side. Right now, I want to talk a little bit about the El Nino and La Nina patterns. Now, El Nino is the warmer water in the equatorial Pacific. This is over 3,000 miles away from us, but has a big effect on our weather here in Colorado. Throws a lot of energy up into the atmosphere, changes the position of thunderstorms in the Pacific, and eventually alters how the jet stream blows across the United States, generally bringing us a southwest to northeast jet stream flow that typically will bring us a lot of big soggy storms in the wintertime and kind of supercharges the summer monsoon in July and August. So the El Nino tends to make it a wetter pattern for Colorado. Sadly, we're in a La Nina, and that's been going on for a while. In La Nina patterns, it's cooler water in the Pacific. It also affects the energy balance of the atmosphere and affects the jet stream, and tends to develop more of a northwesterly flow across the nation from northwest to southeast. In the wintertime, that is great for Summit County and great for Steamboat at the expense of the San Juan Mountains. And it generally means a lot of wind on the eastern plains, which we've certainly seen so far this year. So that pattern is going to continue, and I'm afraid it means that perhaps one of our biggest things we're going to worry about this year is going to be fire danger throughout the entire summer. This, of course, is from the terrible fires on December 30th. So what are we looking forward to as far as the next 90 days? Well, long-range prediction calling for hotter than normal conditions or average conditions over the summer, and drier, hot and dry, and that is going to mean, although we'll get some thunderstorm activity, I think we're mostly going to be worried about fire weather for much of the upcoming season. Now, where does your forecast come from? Northeast Colorado, that's the National Weather Service office out of Boulder. Southeast Colorado is the National Weather Service out of Pueblo. The extreme eastern counties, Yuma County, Kit Carson, and Cheyenne, are handled by the National Weather Service office out of Goodland, Kansas. And out west, the folks at the Grand Junction National Weather Service office handle all that forecasting. Here's one. Where am I? A lot of different regions in Colorado. Cheyenne Ridge, Palmer Divide, Raton Ridge, those are all west to east higher terrain. Monument Hill is the Palmer Divide. And as the air rises and sinks over those, it has an impact on the weather. Oftentimes drier when that air is sinking and wetter when it's rising. Front Range, adjacent foothills right here. Here's the Sangre de Cristos, the San Luis Valley, great sand dunes, like right down in here. Southwest Mountains, the Grand Mesa, Western Slope, Central Mountains, Northern Mountains. So when we talk about those on a weathercast, these are the areas that we're referring to. Give you a little point here on the Palmer Divide. So here's the Palmer Divide right here. When we have a wind in the cool season that's blowing in from the northeast, that forces the air to rise up over the Palmer Divide. It drops its moisture. We get some of our heaviest snows on the southwest side of the Denver area, including the Palmer Divide. That sinking air coming down into Colorado Springs, so they don't see very much in the way of snowfall in that particular spot. But in the summertime, if we have southeasterly winds that blow over the Palmer Divide, there's something called the Denver cyclone. And what happens is the air comes down off the divide and it curls back toward the Denver area. Now, if we get thunderstorms that develop in the mountains, they're kind of moving off the mountains. They run into this air coming in from the southeast. You get a convergence line right over the Denver area from about Castle Rock through Aurora up to DIA, extending up into Weld County. And along that convergence line, we can get tornadoes that form because the air's coming together, it starts to spin. It can also cause occasionally tornadoes that will happen in higher terrain. Most of our tornadoes occur east of I-25. Only about 10% occur west of I-25, but they can indeed happen. As you see on this map, it's a little hard maybe to make out, but almost all the tornadoes are east of I-25, very few in the western counties. Here's the classic map of Tornado Alley for the central United States. We're seeing with climate change that we're actually getting more tornadoes now forming down here in Kentucky, Tennessee, Alabama, Georgia. But traditionally, this has been Tornado Alley. Warm, moist air feeds up from the south. Cool, dry air comes down from the northwest, and they collide, and that forces the air to rise. You get a lot of thunderstorms that build here. Now, if we didn't have this warm, dry air coming off of the plateau, the higher terrain in New Mexico and down in Arizona, we'd probably get a lot of thunderstorms that develop earlier in the day. But what happens is this warm air here rises up, and at about 10 to 15,000 feet up in the sky, it forms a layer of warmer air that we call a cap. If you think about it, if you have a bottle of soda, you take the cap off, put your thumb on the top of that and shake it up. Your thumb is the cap. When you release the cap, the whole thing blows up into a really big mess. Well, when the cap here breaks, when it gets enough heat all building at the surface and you finally break through the cap, then these thunderstorms just explode and develop very rapidly, and that's where we see the storms that can get all the way up into the jet stream and form really severe thunderstorms and tornadoes. So we get about 45 to 50 tornadoes a year here in Colorado. Texas tends to get about 150, but we're right on the western edge of Tornado Alley. Watches and warnings. Watch means watch out, something may happen. Warning means something is happening. So if we issue a severe thunderstorm watch, that means there could be severe thunderstorms. Same thing with the tornado watch. Goes on for a period of about 5 to 7 hours. A warning means there is a severe thunderstorm, or there is either an actual tornado or we're seeing the rotation that could be a tornado. When you look at clouds that are building, the big cumulus clouds, look at the shape of them. If they're kind of fuzzy looking, that means the updraft isn't all that strong. But if they're very crisp like cauliflower, that means that that air is exploding high up into the storm at a very violent or rapid rate. And it's that crisp cloud that means a very strong updraft that can produce severe thunderstorms. Now, they're beautiful. These are mammatus clouds, the little bubbles that form underneath the anvil. They're not harmful. They're symbols of a lot of turbulence in the air. Oftentimes late in the day they make beautiful pictures as they're kind of moving off to the east away from us. But they are on a distant anvil of a cloud. This is a rotating supercell thunderstorm. The whole storm is spinning because it's gone way up into the jet stream. And storm chasers call these striations. They're like a stack of plates. Sometimes we call it a mothership. They're very dramatic, and they're often seen on the eastern plains of Colorado. Be careful. The lightning, of course, can go way out far from where the base of that storm is. And this is what we call a barber pole effect. That whole storm is spinning just like a barber pole would be, the inflow going in and the updraft taking it up. You can see how that would translate eventually into a tornado that could come down to the ground. If you storm chase, a couple of things. Number one, don't do it unless you know what you're doing. The National Weather Service actually has classes on that people can take and learn how to do this. Don't just grab your phone and go out there not knowing how to do this, because it can be very, very dangerous. But the best way to approach a severe thunderstorm is from a more southern angle. That keeps you out of the heaviest precipitation on the north side of the storm, and it also makes sure you have a good road system so you can get in and out and away from the storm. But I really urge you, don't do this unless you have taken classes, you know what you're doing. If you ever see something like this, my friend Roger Hill, who's in the Guinness Book of World Records, he has seen over 850 tornadoes. He's seen more tornadoes than any other human being. He captures 3 in one day. If you ever did that, I think you just call that certainly a career day. And here is another one. I guess Roger's currently at 805 on tornadoes, excuse me on that. But he has seen a lot of them, and he has a company called Silver Lining Tours. You can look it up. They actually take people on tornado tours. So how do these things form in the first place? Thunderstorms develop because we get an updraft. That'd be like hot air. A hot air balloon rises. So that rises up, the air begins to expand, it cools, it condenses the moisture. Once the moisture condenses, then that starts to drop back down as rain, so you get cool air coming back down. Updraft is warmer air, downdraft is cooler air. If you get an explosive thunderstorm, it gets up high enough to the jet stream. That jet stream going up here creates wind shear, and that's what starts to make that entire thunderstorm begin to spin. And that is when you get a severe thunderstorm. Now you get the cool air coming down, and that's condensing and forms a lowering that rotates called the wall cloud, and from that descends the funnel cloud. A funnel cloud is a tornado that has not reached the ground. So if you hear us say there's been a funnel cloud sighted, that means we have not seen it get down to the ground. But then if you get where you have debris and spinning on the ground, you'd have a tornado. One thing in Colorado to be careful of, our low-level humidity is so low that sometimes that condensation funnel evaporates. So you don't see it coming all the way down to the ground, but you will see dust swirling around. So even if you can't see the condensation funnel all the way down to the ground, you could still have a tornado on the ground. Watch for that. This is the Simla tornado, June of 2015. Out pretty much open country. A lot of times I like to call that natural crop rotation. It's spinning around out there. A very picturesque tornado. Fortunately didn't do much damage because it was in pretty open country. And here's a little joke. If you remember Andy Griffith, they had Otis. He was the guy that was always in jail, and so a spotter pointed out they saw a tornado near Otis, which is the town of Otis. I'll be here all week. Thank you very much. All right, but seriously, tornadoes can be damaging and dangerous, not just on the far eastern plains, but also closer to I-25. This is the Windsor tornado, May of 2008. Unusual because it started early in the day, 11:30 in the morning near Platteville. Unusual because it moved from the southeast to the northwest, and unusual because it caused so much damage and one fatality, $125 million in damage and a fatality. So we can get big damaging tornadoes this close to I-25. We'd have to be farther out on the plains. So I may sometimes talk and say radar has indicated a tornado. Well, what that means is we're using the Doppler radar. Doppler radar not only can see the precipitation, but it can also see if it's moving quickly toward the radar or away from it. A good analogy to explain Doppler is, think about how a race car sounds. It goes as it goes by. As the race car is approaching you, the sound waves are kind of bunching up because it's coming towards you. As it goes by, the sound waves are spreading out and the pitch drops. So we can tell with microwave energy, radar signals, whether raindrops and hailstones are quickly moving toward the radar or away from it. In this case, right here, that's what we call a couplet, where the green is moving toward the radar, the red is moving away. That would be what we call a radar indicated tornado. Another thing we can see with radar is this kind of fish hook right here. We talk about a hook echo. The tornado would be right in there. That was actually the radar from the Windsor tornado. So storm-based warnings are very important. We have big counties in Colorado: Weld County, Larimer County, Adams, Arapahoe. They're great big counties. If we issue a tornado warning for all of Weld County, that's many, many square miles that are being warned for a storm that covers a much smaller area. So this is what we do. Instead of for a whole county, we issue it just for the little polygon that we think the storm is going to stay in. So in the case of the Windsor tornado, it's just this little polygon. And our Storm Shield app and some other apps are available will give you that warning. So that's an important thing to remember. Get the storm-based or the polygon warnings. We have different kinds of tornadoes in Colorado, not just the classic big ones like the Windsor tornado, a supercell tornado, but we have smaller ones that are called landspout tornadoes. And that's a weak tornado that doesn't last for long and generally doesn't cause much damage. These are examples of landspout tornadoes. They tend to be pretty small, but they can still tear some things up a little bit. And we also have something called a gustnado, which, think about when a boat is going along in the water and it makes a big turn and swirls out an eddy of water around it. If we have a big thunderstorm that's kind of blowing out a big gust of wind, it scoops up some dust, Some of that gets caught back into the updraft of a new thunderstorm, and you'll get a spinning column of air, but it's not really like a classic tornado. We probably would not warn for it. We just say that we've seen some gustnados or a few short-lived land spouts. And here's why they happen. Very often, because we don't have that much humidity compared to other parts of the country, which makes our weather really nice in the summertime, but very often we will get bands of thunderstorms that kind of pop up, and they go through a life cycle of their updraft, their condensation, their precipitation, their downdraft, and they'll kind of die away. Well, when they do that, the downdraft hits the ground and fans out in all directions, and so you get two areas of thunderstorms that then produce what we call a boundary or a gust front. That's a gust of air coming out from these thunderstorms, and they can oftentimes collide and form a new area of thunderstorms. So you can actually see this boundary on radar. It may not be precipitation, it might actually be bugs, and the bugs can actually cause the, let me get rid of that real quick. There we go. The bugs can bounce back on the radar and you'll see them, and when they collide, you'll get new thunderstorms that develop. Got so excited about the bugs. So when that rotation, when that air kind of comes together, it's drawn up into the updraft, and very often a land spout tornado will actually be bigger on the bottom than it is on the top. It's a non-supercell tornado, still can be fairly strong, maybe an EF 0 or 1, which can cause some damage. Let's talk about that scale. We rate tornadoes with the EF, or the Enhanced Fujita scale. An EF 0 or 1 is a weak tornado. It'll cause a little bit of damage, knock down some branches, maybe some shingles off the roof. When you get up to a 2, that's getting to be a pretty strong tornado, winds of 111 to 135 miles per hour, and that will cause roof damage, blow out windows, and really wreck up trees. An EF3, which is what the Windsor tornado is, will take roofs off houses, do a lot of damage on buildings, blow all the windows out of cars, flip them over. Those are winds of 136 to 165 miles per hour. And an EF4 is a violent tornado with winds up to 200 miles per hour. The EF5, that's the finger of God from Twister, and that was incredible damage. Fortunately, only a few tornadoes a year, if that many, anywhere in the country become EF5s. Rotating supercells, that's that mother ship we showed you, the stack of dinner plates, the barber pole. That's what they look like. Sometimes we call them a mother ship. It looks like something from perhaps the movie Independence Day. And they come in different flavors. An LP supercell is a low precipitation supercell. Produces some large hail, not necessarily out of heavy rain. Very picturesque. I mean, that thing is amazing looking. And we get a lot of these in Colorado because our surface humidity is relatively low. They're not as common in more humid parts of the country. An HP supercell is a high precipitation supercell. Very dangerous because in this area here, that's large hail, heavy rain, and maybe a tornado. So you don't like to chase these because you can't always see. This would be like in the bear's cage, as they talked about in the movie Twister. Very dangerous storms. And I want to, again, if you're going to go chasing, and only do this if you know what you're doing or you go with somebody that knows how to do it, make sure you have good roads, because a road like this, when it rains, that dirt turns into mud and you can get stuck in the mud and be stuck out there for a long time. And it is dangerous. These are three friends of mine. That's Roger Hill. That is Tim Samaras, who used to be my intern here at Denver 7. And he has seen over, I think, 350 tornadoes, maybe 400 now. And this was me speaking at the memorial for the late, great Tim Samaras, who was perhaps the greatest of all storm chasers. He invented devices to put in front of the tornadoes. He was the most cautious storm chaser, and he and his son and chase partner were all killed in the El Reno tornado in Oklahoma in 2013. I liken it to an astronaut. Strapping yourself onto a rocket is inherently dangerous. Chasing severe thunderstorms and tornadoes is also inherently dangerous. You do the best you can to be safe, but again, these are the best of the best. Don't go chasing unless you or somebody you're going with knows what they're doing. Lightning is a major hazard. Remember that it's not lightening, it's lightning, and it takes 5 seconds for the sound to travel 1 mile. So if you're outside and you see lightning, start to count. 1, 2, 3, 4, 5. Keep counting until you hear the thunder. If you count to 15, 15 divided by 5, it's 3 miles away. You count to 10, it's only 2 miles away. You count to 5, that lightning is right there. If you can hear the thunder, it's actually close enough to be deadly. So when thunder roars, go indoors. And then there's hail. Boy, do we get hail around here. We're a little higher up because we're in the front range of the Rockies, so those storms are a little closer to the colder air, and we get a lot of hailstorms here, especially May, June, early July. The 7/11/1990 hailstorm was a bad one, and then just 5 years ago we had a terrible hailstorm that hit in early May on the northwest side of Denver. If you see these streaks like that, that's actually hail falling out of the cloud off into the distance, and they can cause a whole ton of danger and damage. Another thing, straight line winds. That's when the wind isn't a tornado but comes down from the storm and fans out in all directions. We call it a downburst or a microburst, and those are very dangerous. They can have winds that sometimes will reach speeds of perhaps 100 miles per hour. Flash flooding. Even as little as 6 inches of water can knock over and carry away an adult. 12 inches of water, fast-moving water, can carry away a small car, and when a car goes floating off into a flood, it doesn't float like a boat. The engine is heavy. It goes down like this and flips over. And as much as 18 inches of water could carry away a large SUV, a van, or a truck. We can get flooding in different times. September is normally the nicest month of the year, except in 2013 when we had the massive front range floods, when some areas had a year's worth of rain in just a few days. Speaking of rain, become a CocoRa's volunteer. CocoRa's means Community Collaborative Rain, Hail, and Snow Study. If you go to cocoras.org, you can get a rain gauge and a hail pad, and you can become one of 20,000 CocoRa's volunteers around the world. It all started here in Colorado. The state climatologist Nolan Duskin starting it back in the late 1990s. We have our Viero camera network. This is an exclusive only on Denver 7, where we have cameras all over Colorado to help keep an eye on the skies. And here are some good weather apps and websites I recommend. Storm Shield is our weather app. Gives you great weather warnings. It's free. Radar Scope is great on your phone. It's not free. I think a subscription annually is maybe about $20 or something. Very good, though, to track thunderstorms on your phone. WeatherTap.com I highly recommend. This is the Storm Prediction Center, spc.noaa.gov, and then there's the Iowa Mesonet. If you can make a screen grab there, it's https://mesonet.agron.iowastate.edu.vtech. I've been playing with that one. Look it up. It's pretty good. And another great weather resource, check this out. This is my new book on climate change, the world's littlest book on climate, 10 facts in 10 minutes about carbon dioxide. You can get a free download of this book by going to that email address, that website address. Well, that's all on Colorado severe weather. Thank you for tuning in. Be careful out there. Remember, Denver 7 will always be there when the skies start to turn threatening. I'm Mike Nelson.